Okay, so 64, it asks what the contrapositive of the statement is. So we're going to write out the rules that we need to know again. So for conditional, it's P, then Q, converse, Q, then P, inverse, not P, not Q, and then contrapositive is not Q, then not P. So for contrapositive, we need this one, not Q, not P. So it'll be not bump head, and then not tall. And that's the one I'm looking for. So if I do not bump my head, then I'm not tall. Okay, for 65, it says the diagram below shows a part of a roof. The highest part of the roof is called the apex. How many feet above the base is the apex of the roof? So we need to know this length right here. And it gives us a bunch of numbers. It shows that these are perpendicular, so these are all parallel to each other, meaning that all these segments are proportional. I'm going to pull out similar triangles. So this triangle right here, this little one, is 4 feet by 5 feet. So I just pulled that one out right here. And then this larger triangle is similar to that, so I'm going to take it out like this. And for this larger triangle, I'm trying to find this height right here, and then this length is 15. And so I'm going to set up a proportion, so this corresponds with this in the same ratio that this corresponds with this. So I'm going to set it up 4 over x equals 5 over 15. And then cross multiply. 5x equals 60 divided by 5, and x equals 12. Okay, next one. Here's this one right here. In the diagram below, ABCD is similar to EFG. AB, segment AB to EF is in a 3:2 ratio. That's like the scale factor of 3:2. It doesn't mean that's the length, it's like the factor that it's related by. It says the perimeter of ABCD is 12. What is the perimeter of EFGH? So it's in a 3:2 ratio. So AB to EF, and then the perimeter of ABCD is 12. What is the perimeter of EFGHX? So we're going to cross multiply, get 3x, 2 times 12 is 24, divided by 3, and x equals 8. D. Okay, 67, in the figure below, K is parallel to M. Cool. What is the value of y right here? Well, in order to find y, we have to know what this angle is. Those are supplementary. We have these two right here. These angles, they're not equal, but they are supplementary. So 3x plus 20 plus 5x plus 40 equals 180 degrees, and we can use that to find x. Combine like terms, I get 8x, 20, and 40. X equals 15. But it's not asking for x, it's asking for y. So I'm going to find this angle here by plugging in 15. So 3 times 15 plus 20. 45 plus 20 is 65. So that's this angle here. And then y is supplementary to that. So 180 minus 65 will give me y. So 115 is y. Okay, when you're ready, just flip the page. We're going to go to 68. 68's a weird one. It's a proof, which generally isn't that bad, but what they did is they put these statements and reasons in the wrong order, and you have to figure out what the correct order is. So which of these is the most logical order for the statements and reasons? So it says given AD is parallel to EC, it says AD is congruent to EC, and we're trying to prove that AB is congruent to CB here. Okay, well, first in our proofs, it always should start out with the given. So the third reason should actually go first. Given would go first. So I guess we'll like cross that out because we've used it. And then over in the answer choices, I can cross out these two and I just have the given. And then it has next, in both of these answer choices that I know have to be right because given's first, it says 2 next. So next it says vertical angles congruent, vertical angles. So this is equal to this is their next step. And then in both of these answer choices, 5 is next, which says that, okay, if two parallel lines, your alternate interior angles are equal. DAB, this angle is equal to ECB. So that would be 5 alternate interior angles. And then it's between 1 and 4. Okay, looking at what I have angle, angle, side, angle, angle, side. That would have to come next. So triangle, let's see. So that would be, I don't know how to put it. It's Roman numeral 1. Angle, angle, side would come next. And then the last part for the CPCTC would be last. So if your triangles are congruent, you can say all the corresponding parts are equal. Okay. 69. Back to normal problems. A truck is at the top of a ramp shown. Oof, it's blurry. Truck is at the top of the ramp. Approximately how high above the ground is the truck? So we're trying to find this length. We're going to use trigonometry. So from this angle, we have opposite and hypotenuse. So using SOHCAHTOA, sine of 26 is x over 4. And then multiply both sides by 4. 4 sine of 26 equals x. X equals 1.75 t. Next, over here, 70. If a cube with side length 6 inches has dimensions divided in half, what will the volume of the new cube be? So volume of a cube is like length times width times height. It's saying that the original has side length of 6. If it's divided in half, then the side would be 3. So 3 times 3 times 3 would give you the new volume. So 27 inches cubed. Okay, this one is a bit weird. When viewed from above, the base of a water fountain has the shape of a hexagon composed of a square and 2 congruent isosceles right triangles. Okay, cool. Which of the following measurements best represents the perimeter of the water fountain's base in feet? Okay, so it shows this whole thing is 40. We have 10 here. This would also be 10 over here. So this must be 20, and this would be 20. This height is, oh, this would be 20 as well. And then to find these side lengths, we could actually use the 45, 45, 90 special right triangles to find the side lengths. So using special right triangles, we can divide 20 by square root of 2 to get this. I know this is weird, but 20 over square root of 2 is this length, which will be all of these. This would be 20 over square root of 2. So with this over here, and 20 over square root of 2. So we got 4 of them. So times 4 over 1 would be 80 over square root of 2. But we can't have that square root as a denominator. So we multiply by square root of 2 over square root of 2. 80 square root of 2 over 2. And I get 1 and 40. So all of these sides are 40 square root of 2 plus 20 plus 20, which is 40. That was weird. But it is in the answer choices. That's cool. Okay, 72. What is the area in square inches of the triangle below? When you have an equilateral triangle like this with an altitude, this actually is a 30, 60, 90 special right triangle, and it follows the rules for 30, 60, 90. So what is the area? Area of a triangle is 1/2 base times height. You have the base is 10, but we don't know the height here, but we can use special right triangles to figure it out. So this would be 5, and then using special right triangles, the height right here would be 5 square root of 3. And so 1/2 of 10 would be 5, 5 square root of 3, so that would be 25 square root of 3. Okay, next, 73. Triangle RST and VSU are shown. It says that this angle and this angle are equal, and it shows that. It shows that RT is equal to this. What additional condition is sufficient to prove that RS is congruent to SV? So we want to prove that RS is equal to SV. Well, if we prove that the triangles are congruent, then we can prove that this is equal to this side right here. So looking at this, it says TS being equal to SU. That would just give us angle side side, which isn't a congruent statement, so not that. VS being perpendicular to RU, actually that probably would, because it gives you angle side, which is a congruent statement, and then you could prove the additional parts are equal. RS to SU, no, those aren't even equal. VUS and RST, those aren't even equal. So it's just that. Use the proof to answer the questions below. AB is congruent to BC. D is a midpoint. Okay, so looking at the proof, because this is a midpoint, then this is equal to this. Got it. Then this is equal to this because of reflexive property. So we have side, side, side. D. That one was easy. Next one, another proof, no way around it. Given that 2 is equal to 3, cool, prove that 1 is equal to 4. Well, 2 is equal to 3, and then they say, okay, 1 is equal to 2, and 3 is equal to 4. Those are vertical angles, so vertical angle theorem. And that's what I'd be looking for. Next, 6. A right circular cone has a radius of 5 inches and a height of 8. What is the lateral area of a cone? Okay, well, surface area of a cone is area of the base plus pi RL. That's on the reference sheet right here. Surface area of the base plus pi RL. Okay, lateral area is just all the way around. All the way around. It's like not including the base. So for just lateral, I'm not going to use this. I'm just going to do pi r slant height. L is slant height. This right here. Okay, so pi, the radius is 5, but then when I go to find slant height, it's not even there. So we have to actually solve for slant height using Pythagorean theorem in this right triangle. 5 squared plus 8 squared equals c squared, and that will give us the slant height. So 25 plus 64 equals c squared. And that would be 89 square root of 89. So this is square root of 89. That goes here. And then I'm like wondering how it wants me to put this in the calculator, but then when you look over here, it's just in that format. They left it. Okay, when you're ready to go to the next page, just flip it. 77. We're going to like 83 today. We're going to 83, so we're almost there. 77. Okay, a new pipeline is being constructed to reroute its oil flow around the exterior of this preserve. The plan showing the old pipeline and new route is shown. How many extra miles will the oil flow once the new route is established? Okay, so we got to find the difference. So the new pipeline was 60 plus 32, which would be 92 miles. And the old one, this route right here, we're going to use Pythagorean theorem. 32 squared plus 60 squared equals c squared. And that would be 1024 plus 3600 equals c squared. 4624 equals c squared. Square root of both sides. And I get c equals 68. So this is 68 miles. And then we need to find the difference between the old and the new. And the difference is 24 miles. A. Okay, next one, it says the point -3, 2 lie on the circle whose equation looks like this. Which of the following must be true about the radius? Well, we can find the center from the equation. The center would be -3, -1. And then it says this lies on the circle. On circle is -3, 2. So if we find the distance between these 2 points, we can find the radius. Distance between these 2 points is the radius of the circle. Like the distance between the center and the point on the circle would be the radius. Sometimes you might have to use distance formula, but in this case, the x's are the same, so we can just find the distance here, and that would be 3 units. 2 minus -1 equals 3 units. So the radius is 3. (79) In the figure below, if sine of x is 5/13, what is cosine and tan, like the ratios? Well, sine, let's see, SOHCAHTOA, I'm going to use this, is opposite over hypotenuse. So from this, opposite would be right here, hypotenuse, opposite, hypotenuse, and then this would be adjacent. I need to find this length so I can find the other ratios, and I can use Pythagorean theorem to find this missing length. So let's just say a squared plus 5 squared equals 13 squared plus 25 equals 169. A squared equals 144. Square root a equals 12. So this here is 12. And then for my ratios, let's see, cosine theta is adjacent over hypotenuse, so that would be 12/13. And for tan of theta, opposite over adjacent would be 5/12. And that's what I'm looking for. So not this one, not this one. It would be A. Three more. Almost there. Ready? Okay, over here, triangle ABC is rotated 180 degrees about the origin. What are the coordinates of A prime? For 180-degree rotation, x, y becomes negative x, negative y. So for point A, which is at 5, 4, A prime would then be at negative 5, negative 4. Oh, I didn't realize you couldn't see that. Negative 5, negative 4. Next one. This one is kind of weird. It has triangles within triangles. It says, what is the length of the altitude CD? So we're trying to figure out what this is. Best way to do this is to split up the triangles. So there's a triangle here, there's a triangle here, and then there's a larger triangle. And all of these triangles are similar to each other. So I'm going to take out the small triangle right here. And the dimensions of this are 3 and x right there. And then the medium triangle, yeah, x and 12. And then the largest triangle, the hypotenuse is 15. Okay, and like I said, all of these are similar. We're trying to find x. So now that we have it all drawn out, this is proportional to this in the same ratio that this is proportional to this, and we can set up a ratio. So 3 over x equals x over 12. And we can cross multiply. X equals 6. Okay, 82. What is the converse of the following statement? Converse is Q, then P. So he will wear a red swimsuit. Red is swimsuit. If Gerald goes swimming. Gerald swimming. And that's what I'm looking for. Where's red swimsuit? He will go swimming. Okay. One more on the back of this. So just flip your page when you're ready. Okay. 83. Last one. Sector of a circle is created from the central angle of 60 degrees. So we got a circle, a sector, 60 degrees, and we're trying to find the area of the sector. So we do 60 degrees over 360 degrees, part over whole, area of sector over area of circle. But we need to find the area of the circle, so we'll do that up here. Area of a circle is pi r squared. It says the diameter is 6 inches, so the radius is 3. So we get 9 pi for the area. Oh, I didn't realize you couldn't see that. There we go. I'm going to leave this in terms of pi because the answer choices are in terms of pi. So now I have 60 over 360 equals area of the sector over 9 pi. And I'll cross multiply. 360x equals 60 times 9, 540 pi. Divided by 360, x equals 54 and 36 can both be divided by 18. And I get 3 over 2 pi. So that would be D. And that is all. Okay, go ahead and turn your paper in, and then I'll use this recording from other classes.